the Genesis project, so we start with an introduction of Leitat, which will be done by Adam. So I give the word to Adam.
Okay, thanks Marcel. Can everyone hear me okay?
Yes.
Wonderful. So first I'll just give us a bit of background into Leitat. So originally we were founded just over 100 years ago in Spain, and it started off relatively small group of industrialists from the Wool Textile Centre got together and basically said, how can we innovate better? How can we find some solutions to business needs? This continues even to now, despite us moving somewhat away from, well, maintaining wool, but expanding. So nowadays we have expertise offering innovative and disruptive solutions to a wide variety of businesses and different organisations. So now we aim to stand for the management of innovative technologies, furthering the creativity and talents of people at a global level. So in terms of the Leitat team, we're a young, diverse and highly skilled team of professionals, if I don't say so myself. And our values include having the right attitude and approach to trying to solve technological challenges, being respectful, and also cooperation between us and other institutions, organisations and entities. So going beyond wool, we have 5 major business areas. This includes health and biomedicine. This includes food technologies, regenerative medicine, biosensors, skin health, cosmetics, bioanalytics, just to name a few. Then circular economy, which focuses on sustainability, air treatment, waste, co-products, water treatment. Energy and engineering, which includes energy conversion and storage, robotics, automation. Then applied chemistry and materials, includes material synthesis, formulation, processing, validation. And then finally, advanced technology services, which includes material certifications, material aging, fire testing, physical properties. These interconnect areas we'll find often on different projects. They'll work together, these different teams, to try and deliver the best solution possible in a more of an interdisciplinary approach. So in terms of our facilities, based in Spain with a number of sort of hubs, largely focused in the Catalonia region, with our headquarters in Terrassa, which is a few kilometres to the northwest of Barcelona, and a number of facilities within Barcelona itself. The different technology areas are represented in different labs at these different locations. In terms of Leitat ourselves and a few sort of headline figures, we're one of the highest impact technology centres in Spain, and within Europe we are leaders in nanotech, materials, biotech and processing. We have a significant client portfolio and a revenue of approximately 27 million euros. And at the moment we've completed 95 R&D projects representing almost 600 million euros in terms of R&D budget, collaborating with over 750 partners across 48 countries. At the moment we're maintaining approximately 350 contracts with industry, offering our technical services, which I'll go into shortly. And over the years we've offered over 4,000 high-tech solutions. Beyond our R&D projects, we also offer lab testing, certification, business incubation services for startups, our Centre of Excellence services, and also spin-off and IPR management. We follow a principle of open innovation, working with and collaborating with numerous entities, organisations, and maintaining those relationships as well. And really our kind of key values include the flexibility, as shown from wool to nanotech, excellent in terms of our successful implementation of hundreds of research and development actions with happy customers, sustainability, not just promoting and developing green technologies and advocating their use, but also analysing our own impact and their externalities. And then finally acting with social responsibility through technology transfer, bringing direct impact and changes to businesses and wider society. So I'll hand over to Marcel's capable hands to explain the technology side much better.
Okay, thank you, Adam. So here's some projects which are related to our CO2 capture or membranes. So the first project we have here is Biocon CO2. Biocon CO2 uses biological processes to transform CO2 waste from the iron, steel, and cement industry into valued-added chemicals and plastics. The next is the Liberate project. The Liberate project has the objective to design of an electrochemical pilot plant to demonstrate the commercial opportunities of converting low-cost lignin feedstock into high valuable biosustainable chemicals such as vanillin, antioxidants, and polyamide. The next one was an FPC project, which was Novartis. The objective of the Novartis project was to develop of a membrane system for seawater desalination that does not suffer from organic fouling and inorganic scaling. The next project was a Horizon project, MEDUS. The MEDUS project was about desalination of seawater also by developing a sustainable low energy process of using microbial desalination cells. The project ended this year, so the last project is that started this year is the New Skin project. This is about the creation of an open innovation testbed for nano-enabled surfaces and membranes to provide efficient and cost-effective innovation processes to manufacture nano-enabled industrial and consumer products. So, shall I take over the presentation, or can I pass the slides, or
I can jump ahead for you if that works.
I don't have control, no?
I don't believe so. You can just tell me when to go next.
Okay, yes. So this is about the Genesis project. The Genesis project with the title High Performance MOF and IPOSS Enhanced Membrane System as Next Generation CO2 Capture Technologies, which is funded under the call NMBP 2017. The scope of the call was high materials for optimizing carbon dioxide capture. So it's a 4-year project which started in January 2018. We have about 8 million of EU contribution, and the project aims to develop and upscale some of the most promising materials for CO2 capture and demonstrate the performance, durability, and reliability in industrial environments. So next slide, please. So here you can see the project partners of the Genesis project. It consists of 16 partners. We have 2 universities from the Netherlands, which are TU Delft and the University of Twente. There are several research centers, SINTEF from Norway, TNO from the Netherlands, and Leitat and ICN2 from Spain. 2 small membrane companies from France, which are Auralis and CTI, focus on ceramic and polymeric membranes. Simulation and modeling partner EPFL from Switzerland. Partners in nanomaterial synthesis and scale-up, which are ICN2 from Spain, MOF technology from the UK, and SINTEF and Functionano from Norway. We have a system engineering company, Jotvat from Israel, and partners from industry, which are Swenk from Latvia, ArcelorMittal from Belgium, and Cemex from Switzerland. And the partner taking care of technology transfer and IPM management is Cambridge Nanomaterials Technology from the UK. So next slide, please. So atmospheric warming due to greenhouse gases has become a serial global concern. In the graph on the left, you can see the yearly carbon emissions starting from the 1950s. And if we follow the current path, carbon emissions will be doubled in the year 2050. It will cause a significant global warming. The impact of global warming we will notice by extreme weather, water shortage, diseases, and melting of the polar ice caps, causing a rise in sea levels worldwide. So ending up with a polar bear and his friends on a piece of ice in the middle of the ocean. If we can limit atmospheric CO2 increase and maintain the current carbon emissions, we would prevent the severe climate damage by 2050. Nevertheless, only carbon capture will not be sufficient to achieve these goals. If the Genesis capture technology would be implemented worldwide, we would achieve about 40% reduction in carbon, which is not enough. So more measures are needed, such as CO2 mitigation and reuse of CO2. Also, renewable energies are necessary to achieve these goals. On the right side, we can see countries with the highest carbon emissions, which are Russia, USA, UK, European Union, and China. With China far and away the world's top CO2 emitter. If we want to reduce the carbon emissions significantly, commitment worldwide is extremely important. With the Paris Climate Agreement, we have made an important first step by committing to keep the increase in global average temperature below 2 degrees Celsius. Carbon taxes have been implemented in 25 countries, while 46 countries put some form of price on carbon, either through taxes or emission trading schemes. So next slide, please. While the scientific world generally agrees that global warming is caused by human activities in the last century with the industrialization, the difference in opinions are by now political and economical motivated. One good example here is Donald Trump, who is not a big believer in global warming. He replaced President Barack Obama's Clean Power Plan, and more recently the US decided to withdraw from the Paris Climate Agreement on November 2020. You can see a similar trend on smaller scale within Europe, which we found out when we were writing the Genesis proposal. Some companies are simply not interested, or carbon capture has not a high priority. One of the responses we got back from a company we contacted was the following. No, we don't do anything about CCS anymore. In fact, it surprises me that you work on this initiative. I thought CCS already died a few years ago. Personally, I would not spend a penny in this technology. Luckily, until now, the political climate in Europe is much different in comparison to the US, with the European Commission having a leading role in carbon capture with their climate and energy policy frameworks. And therefore, Europe has currently the world's most ambitious climate and energy objectives for 2030. Next slide, please. So there are three main processes to separate carbon dioxide from other gases, which are pre-combustion, post-combustion, and oxy-fuel combustion. In the Genesis, we will focus on the first two. In post-combustion capture, the CO2 is separated from combustion exhaust gases. Next slide, please. Which are mainly a mixture of nitrogen and CO2. Post-combustion capture can be retrofitted to most industries and existing power plants. The CO2 can be separated using solvents, absorption, or other methods such as membranes, solid sorbents, or cryogenic technologies. The captured CO2 can be compressed and transported for storage. Pre-combustion processes deal with syngas, a gaseous mixture created by conversion of solid, liquid, or gaseous fuel consisting of hydrogen, carbon monoxide, and CO2. The carbon monoxide is converted to CO2, and the hydrogen is separated and can be burned without producing any CO2 emissions. The fuel conversion step required for pre-combustions are complex, involving high pressure and high temperature, making the technology only applicable to specific facilities or power plants. However, the reforming of gas is well established and has been used for decades at refineries and chemical plants around the world. Oxy-fuel combustion is a process of burning fuel using pure oxygen instead of air. This produces exhaust gas, which is mainly water vapor, and CO2, which can be easily separated and produce a high-purity CO2 stream. Here in this graph, you can see the solvent absorption technology uses amine is currently the most advanced of all capture technologies. So the cost reduction here is the lowest, but the time to commercialization is also the lowest. If you go to the right, time to commercialization will be longer and more cost reduction can be achieved. So in the Genesis project, we work on membrane systems and on MOFs. Next slide, please. So the Genesis project is focused on pre-combustion and post-combustion, as I said before, combining nanomaterials and the membranes as alternative approach for CO2 capture. Here we can see the general Genesis approach. The project started at a technology readiness level of 4, and by the end of the project, we will reach a TRL of about 6. The project is roughly divided in 3 phases. The first phase is material development by universities, technology centers, and SMEs, followed by validation and upscaling, and finally demonstration of the technology at industrial scale in cement and steel industry. Next slide. So the Genesis built up on 2 previous projects, which are Carina and M4CO2. In Carina, the IPOSS ceramic membranes were developed. IPOSS is a hypercross-linked network of alternating covalently bonded amide and POS groups. The membrane is formed by an interfacial polymerization reaction, And the thin IPOSS membranes has unique properties due to the alternating connections between the organic bridges and the POS, showing high hydrogen permeances, selectivities, and thermal stability, which are ideal for pre-combustion applications. The interfacial polymerization synthesis of IPOSS membranes is comparable to the fabrication of aero membranes. Therefore, the IPOSS membrane fabrication can be scaled up and produced at larger scale. In the M4CO2 project, a hybrid membrane concept was developed, which consisted of a metal organic framework, nanomaterial dispersed within a polymer matrix. One main advantage of MOF over other solid materials is the possibility to tailor the pore size and functionality. These hybrid membranes show significant improved separation performance in comparison with pure polymer systems for carbon capture. The polymeric MOF membranes are relatively cheap, which make them an interesting option for post-combustion applications. And also the fabrication at large scale is feasible with some minor changes of existing technology, which will make them promising as a short-term solution. Next slide, please. So here you can see the two membrane systems developed in the Genesis project. On the top, you see the MOF membrane system. The MOF membrane system is based on polymeric membranes and have a multi-layer concept. At the beginning of the project, a MOF screening was done to select the most suitable MOFs for CO2 and nitrogen separation. The MOF site was optimized and MOF dispersion were prepared for incorporation of the MOF into the membrane. Small membrane samples were fabricated and gas separation performance was tested, which will be followed by upscaling of the membranes, fabrication of modular membrane elements, which will be demonstrated at industrial scale. For the IPOSS membrane, the POS building blocks were optimized, which you see on the lower part of the screen, and to increase the thermal stability. The IPOSS membrane was synthesized on small samples and the gas separation performances were tested. The IPOSS synthesis was upscaled from disk to singular channel and finally to a multi-channel ceramic membranes. And the performance of the multi-channel membranes will be tested for separation of hydrogen and CO2 in the project. Next slide, please. So here you see the overall work plan structure of the Genesis project. It's divided in 9 work packages. In work package 1, we defined the pre-combustion and post-combustion cases and the operational requirements, which was followed by the material development in work package 2 and 3. In work package 4, the development of materials for pre-combustion processes, where in work package 3, the development of materials for post-combustion processes. So then we went to upscaling and prototyping, which is done in work package 4, followed by the validation and integration in work package 5 and 6. Then we have work package 7, which is dedicated to nano-safety, environmental evaluation and economics. We have the dissemination and IPR in work package 8. And finally, work package 9 is the management of the project. Next slide, please. Yes. So here we see an overview of the Genesis project. We started in 2018 with the material development on POS and MOF. We incorporated this material into the membranes and into the membranes for MOF polymeric membranes and for IPOSS ceramic membranes. The validation and upscaling we did for both systems, which is followed by system engineering, where we design a pilot and do the pilot construction. We are now at the end of almost 2020. So, and the demonstration will be followed in the last year of the Genesis project. So next slide. So thank you for your attention. Here on the lower side, you can see the website of the Genesis project and some info if you want also to mail us. You also have here the mailing address of Adam, Xavier, and me. So thank you for your attention. And
Thanks.
if you have some